Johnson, and today we're going to be looking at some probability problems for your PSSA prep. The example problem that we'll start with, from a drawer of shirts containing 4 black, 3 green, and 6 purple, what is the probability of randomly choosing a purple shirt? When we look at probability, we are concerned with the number of outcomes. Probability is equal to the ratio of the number of favorable outcomes to the number of total outcomes or total possibilities. In this example, my favorable outcome is a purple shirt. So I'm looking to find the probability of purple. That's the notation that we use for probability. The number of favorable outcomes in this problem is 6, because there are 6 purple shirts in the drawer. The number of total outcomes is 13, because the number of total shirts in the drawer is 13, with the 4 black, the 3 red, and the 6 purple. Since I can't reduce this fraction any further, I leave my answer in that form. The probability of choosing a purple shirt is 6 out of 13, or 6/13. So that was an example of simple probability. Now let's extend the problem to see what happens when we do 2 or more events when we're dealing with probability. So that was an example of simple probability. Now we'll extend a problem to look and see what happens when you choose more than one shirt from the drawer. Suppose you wanted to choose 2 shirts. Find the probability of choosing a black shirt followed by a green shirt. There are 2 different ways that we can look at this problem. The probability words that we need to know are with replacement and without replacement. First, we're going to do this problem with replacement. That means that after you choose the black shirt from the drawer, you're going to put it back into the drawer before you choose the green shirt. When you do multiple events with probability, you use multiplication. So we're going to look at the probability of the first event times the probability of the second. For this problem, the probability of the first event would be choosing a black shirt. And the second event would be choosing a green shirt. The probability of the black shirt we'll find just in the way we found the probability of the purple in the first part of the problem. The number of favorable outcomes divided by the number of total outcomes. We have 4 black shirts in our drawer. So the number of favorable outcomes is 4, and remember the total number of shirts was 13. So the probability of choosing the black shirt is 4 out of 13. Now, remember that we're doing this problem with replacement. That means I'm going to take that black shirt, put it back into the drawer, and then choose the green shirt. So, when I do the second part of the problem, I still have 13 shirts in the drawer. 3 of them are green. So the number of favorable outcomes for the probability of green is 3. And again, since I put that black shirt back, 13 is the total number of shirts. When you multiply, remember multiplying fractions, it's the numerators and the denominators. So the probability is 12 out of 169 for the chance of choosing a black shirt followed by a green shirt with replacement. Now for the last part of the problem, we're going to look at the probability of choosing 2 shirts from the drawer, again a black followed by a green, but this time we're going to do it without replacement, which means that after we remove the black shirt from the drawer, we're not going to put it back with the rest of the shirts. Let's take a look at this problem. Once again, we're going to use the multiplication rule. I want to do the probability of black times the probability of green. The problem starts off in the exact same way. The probability of choosing a black shirt is still 4 out of 13. because there are 4 black shirts in the drawer and 13 shirts total. When we do the second part of the problem, that's when this without replacement becomes very important. I take the black shirt out of the drawer and I don't put it back. There are still 3 green shirts in the drawer because I haven't taken any of the green shirts away. But my total number of possibilities is reduced from 13 down to 12 because of that black shirt that I removed. So now we have 4/13 times 3 over 12. Again, we multiply across the numerators and across the denominators to get 12 out of 156, which we could reduce in order to simplify our answer. So we get 12 out of 156 for the number of possibilities for choosing a black shirt followed by a green shirt without replacement. And of course, we can reduce our answer, dividing both the numerator and the denominator by 12 to 1 out of 13. Now try the problem that you have in front of you, question number 1. So question number 1 asks us, from a class of 16 boys and 12 girls, what is the probability of randomly choosing a boy? Simple probability problem. The favorable outcome here is choosing a boy, and the total outcomes would be the total number of students in the class. So the probability of a boy is 16 out of 28. Total number of boys divided by total number of students, which of course reduces to 4 out of 7 if we divide the numerator and the denominator by 4. So in order to solve probability problems, there's really only a few things you need to remember. Probability is equal to the total number of favorable outcomes divided by the total number of outcomes or possibilities. If you're finding the probability of more than one event, you want to use multiplication. And you want to make sure that you read the problem carefully to see if you're doing a probability with replacement or without replacement, because that will change the probability of the second event when you're multiplying.